Welcome to Tulsa Bioscience Podcast, Chromatography Experts. I'm Phu Duong, Global Commercial Strategist. And today we have a podcast. We will discuss multi-angle light scattering detections. And with me today, I have one of brilliant application scientist, Tianyu Li. I will let Tianyu introduce himself very briefly. Go ahead, Tianyu.
Thank you. My name is Tianyu Li, and I'm the application scientist for ICC and GPC instrument at Tulsa. Thank you.
Well, all right. So let's talk about light scattering detection. Okay, and I know that light scattering detection, particularly when we said it's right, multi-angle light scattering detector, right? Or detection, that depends on, when and where that, we put it. So I want to go back to a very, very basic with you first, okay? Because some of a new scientist who's never get a chance to expose or using, this technology before, but they may they may hear about that. Let's go back to the basic a little bit. How about that?
Yeah, sounds good.
Okay, great. So go ahead and define what is multi-angle light scattering detector or detection.
Yes. Multi-angle light scattering is an analytical technique used to determine absolute molecular weight and size of the macromolecule in solution. And in general, multi-angle light scattering is coupled with size exclusion chromatography, SEC, and when sample pass through the detectors, it will scatter the light at different directions. So the multi-angle light scattering detector collects the intensity of the light at each angle. Then by analyzing the difference between each angles and the intensity of the signals, we can obtain the absolute molecular weight and the size, which is the radius of gyration, RG in this case.
Oh, I see. So is there a limitation in terms of is capacity to detect or measure molecular weight in terms of, for example, like did it discriminate? It only can be used for polymer or it can use for including biomolecules such as proteins, antibodies, viruses, particles, and things like that. So can you explain a little bit more about that?
Yeah, multi-angle light scattering can actually be used for a wide range of the samples, macromolecules. It can be synthetic polymer, natural polymer, and biomolecules. I can give you several famous examples. For example, polystyrene, polyacrylates, polyesters. When we talk about the biosamples, like MAP, AAV, lipid nanoparticle, and so on. So it can be used by a lot of the samples.
Oh, I see. So now, based on what you just explained, so is application, particularly when it comes to measuring the molecular weight or the size of the molecules, I mean, it has a very wide range of application, right? So to me, that it could be one of the key advantage. Because I know that for a fact that people, years ago that, before, or people, do not use, multi-angle light scattering detection. They typically use mass spec. I mean, mass spec is a fantastic method or instrument to do all of that. But why, what is the major difference between selecting, multi-angle light scanning, like method versus, like a mass spec? Can you tell me a little bit about that?
Yeah, like for mass spec and multi-angle light scattering, both techniques can give you the molecular weight. Okay. But multi-angle light scattering can give you more information, more than molecular weight. For example, the size, radius of gyration, which describes the mass distribution of each mass element towards the center of the sample. So let me give you an example for an easy explanation. For example, for a sample with a hollow sphere structure, so all the mass is on the shell of the sample. In that case, the radius of gyration will equal to the radius of the real particles. At the same radius, let we bring a solid sphere particles. So the center of the sphere is filled with mass. In that case, when you calculate radius of gyration, it's the average between from the shell to the center. In that case, the radius of gyration is smaller than the real radius. So with this information, you actually know, like for example, for AAV, you can have a brief idea what about the filling state. So actually, for the real case, the fully filled AAV, the radius of gyration is smaller than the empty AAV.
Oh, so it means that if you don't need, I mean, like for example, like it's this sequence of the molecules, and if you want to measure, molecular weight and size and things like that, it truly is, like multi-angle light scattering detection. It could be a major advantage. Because it looked like, like, I mean, why they have to spend, like so much onto mass spec? Because mass spec is, harder to study too, right? I mean, learning mass spec is a challenge itself, right? The space, the cost, and everything associated with mass spec. So if you only focus on the, the molecular weight, the size, and things like that, light scattering detector is a major advantage.
Yeah,
I see. Yeah. So if we go through that, okay, using the multi-angle light scattering detector, how easy that is can be implemented in any lab setting.
yeah, it's actually pretty simple. It's pretty similar to the SEC UV or SEC RI. It's just the additional detector in series or in split with RI or UV. So for a typical routine of the experiment, you make injection on your SEC, GPC, or HPLC system. The sample pass through the column, then go to different detectors. Then the experiment is done. So it's pretty simple. It's just the additional detector to the like the front end instrument.
Oh, I see. So let me clarify with you one more thing. You mentioned, so much that the method looked like, a very compatible with size exclusion chromatography. What about, like if somebody want to use it with others separation method, such as reverse phase, ion exchange, and things like that. So you think that is capable to do that, or it is compatible with those methods or not?
In principle, it's still compatible. For example, with AEX, they already have published publications on the AEX MALS. But with this setup, they bring some challenges because you have the gradient during the separation. Then the refractive index of the mobile phase it will be changed during the experiment. Then the light scattering baseline sometimes will drifting up or drifting down. In that case, you need to introduce more blanks to do the subtraction of the baseline from the data. So it's give you the ability to run it in the AEX, but it requires you more efforts in data analysis.
Oh, I see. So, I mean, like that's what I found that, is rather interesting about the technology. Because besides, like the size is determined. I was also told that, I mean, correct me because I read a little about this. Besides, like online, inline, some of the malls can also be offline. For example, like you can using the instrument measure the molecular weight directly. You don't have to go through the columns. Is that right?
Yes. For this method, we actually call it batch mode.
Okay.
So, for example, if you have some sample adhesive to the column but with a huge size, instead of use a column, you can use a very, very narrow tubing to behave like a column. So in that case, for our light scattering techniques, we do not need separation.
Okay.
We only need the peak area, which has the intensity of the sample. Based on the intensity difference of the low angle or right angle, you can have the molecular weight. Based on the difference between low angle, high angle, and right angle, you obtain radius of gyration.
I see. Yeah, so it's very, very similar in way that people use in mass spec, right? Because mass spec, you can do inline, online, or you can do offline completely like that. But clearly that, because I just, briefly review some of MALS detectors out there nowadays. I mean, it's truly very, very compact. It is small. It did not need a lot of space. And so it's rather, simple compared to, mass spec nowadays, right? Okay, so now this one a little bit more into the technology and the history of MALS detection. I knew for the fact that multi-angle light scattering, has been in the industry for many, many years. And it's been used, primarily for years that they use, determine molecular weight and size for the polymer. And then eventually they use for biomolecules. So I mean, the technology has been out there for a long time. So is there new innovation, to improve it, or people still, doing the same, or using the same instrument, throughout, the history of MALS?
Yeah. For this question, maybe let me talk about the traditional MALS, the traditional techniques first. Like for the traditional MALS, we will have many angles. Like the lowest can go like 30 degrees. The highest is about 150. So the detectors actually sit at exactly at the angle of the scattering. So if you go to lower or higher angle, for example, 30 degrees, the detector is too close to the incident beam. So in that case, the signal will be influenced significant by the incident beam itself. So the traditional MALS, although it's behavior good, it gives molecular weight RG, but it has the limitation on the RG range. It cannot go lower than 10 nanometers. And with these issues, and people nowadays want to have a more accurate instrument, we have not have the innovation on the techniques. For our total instrument, we have three innovation on the multi-angle light scattering techniques. The two on the instrument design and one on the data analysis. The first one, we have a patented design flow cell. For this flow cell, it's made of PIC, which is a bioinert material. This can reduce the the interrefraction of the laser inside of the flow cell compared with the quartz or glass cells. And then our detector is sit actually perpendicular to the direction of the incident beam. And then we add a refractive mirror inside of the flow path, so the laser at certain angle is reflect to the detector. In that case, the detector is far away from the incident beam. That's why we can have a clean signal at low or even lower and even higher angle. With this design, we can go to more lower and more higher angle, which is 10 degree and 170 degree. Why this is important? Because when you go to extremely low, for example, 10 degree, the angular dependence can kind of be ignored. In that case, you can do a direct measurement of the molecular weight, which is assumption-free. If you do traditionally, like from 30 to 150 degree, based on the size and shape of the sample, sometimes you need to apply different models to fit the data to have the best accurate data. It's kind of a little bit difficult for the users just start with light scattering because there is a learning curve with the techniques. With the assumption-free this innovation, you do not need to worry about this part. And you may ask, like, I know light scattering a lot. I'm not worried about different model. I know which one I should choose. But this innovation will still help because with SEC, we can have separation of the sample. Sometimes the sample have a large distribution, especially for the high molecular weight side. Sometimes the RG may larger than 50 nanometers. In that case, one model cannot be used for the whole separation of the samples. You need to apply several different models for the sample. But as far as I know, there is no software in the market can do a slice-by-slice analysis with different model fitting. So with the assumption-free method, you can actually have accurate results from the first slide to the last slide of your peak.
Yeah. Oh, so you mean that with the new innovation, I mean, I can say, I mean, I can assume or I can say for sure that there's no more assumption and no more extrapolation of the result.
Yeah, like for this part, I would like to make it clarify. We are talking about the molecular weight. When we talk about radius of gyration, that is actually our second innovation. When we talk about radius of gyration, we are comparing the difference between each angles. So in that case, we still need to apply a model to fit the data. But this part, we developed a new method because we know in literature at each shape, for example, random coil, sphere, and the rods, at each at the certain shape at each molecular weight, we actually know how the difference between these three angles. Then we can incorporate the data in the software. After you have your results, we can comparing the scattering profile with different shape at that molecular weight we measure. So based on the difference between the scattering curve, we can actually know the ratio of different shape. So this method, we already published a good publication in JAX with collaboration with Brown University, which discuss how we monitor the transition of the bottle brush polymer with different arm intensities from the random coil shape to the rod-like shape.
So I mean, so based on what you said as well, instead, like selecting a different models for you to do, or different models or a different way to measure your molecular weight. Nowadays, with the new innovation, you don't have to do that anymore. So, I mean, it's just like a detector.
Yeah.
I mean, as long as you can see your peak, you can integrate it without have to worry about selecting a calculation model.
Yes.
Right?
Yes.
Oh, I see. So it's just like a UV detector.
Yeah.
Basically, I mean, yes. So just the ease of use is just right there. So you don't have to, because for a young new scientist, for example, who did not, like, I mean, like, there is truly the difference between a biochemist versus, a chemist versus, a biophysics, right? The way of thinking, the way of training is different. So with the new innovation, even like with the protein biochemist people, that it truly fits and make like they can use the instrument quite effectively. Oh, I see. Now so you make me thinking about because I mean, I was trained as a biochemist, okay, and then to me that I just love the like my molecular weight of my proteins and things like that, and then yes, like go into thinking about select different models and things like that. I mean, yes, I think it's great that they have that available, but nowadays with the new innovation like this. Which is like a fantastic thing to say, to see, yeah, yeah. So now move on to a little bit more. I knew for a fact that because of the ease of use, based on what you see, and based on what you just described to me, yes. proteins and AAVs and everything like that. The calculation is quite different, but look like with your new innovation, the software is very well designed. To me that you see what you will get. Okay, but is there a specific software or any specific thing that like because one thing that I know that when I try to measure the molecular weight of map, of course like a different way to do it, and then like when I measure AAV particles, a different way to do it. So in your software with the new innovation, so everything like that is available.
Yeah, like for different application, for example, for AV, we actually have an AV module inside.
Oh, I see. Okay, that's great. So you make it very, very convenient, like for the user out there. Yeah. Tianyu, yes, everyone nowadays knows that TOSO offers a MALS detector, and it's called MALS LenS3, right? And the MALS LenS3 is truly a new innovation from TOSA Bioscience, and the whole thing about this instrument is about its software, and I remember the software called SetView, right? Can you explain a little bit about like the detector and the SecView software?
Yeah. For our LenS3 detector, we have the patent design on the detector, so the detector is more sensitive, and we can have a more accurate molecular weight determination and the RG determination. For the lowest RG we can go is actually 5 nanometers. For the traditional mouse, they are 10 nanometers. And for our SecView 3 software, we try to make everything simple and easy. So for the different applications, we actually have different module. For example, for polymer users, we have a polymer module. For biomolecule users, we have that module as well. And we also have that AV module for our AV users specifically. Because for AV analysis, it requires more information than the traditional method compared with polymer and biomolecules. You will need UV extension coefficient, molecular weight of the capsid, and the input as single-strand DNA or RNA. So when inside of the AV module, if you know your sequence of the samples, you can pre-calculate everything. After you input everything, it's just assign the baseline, makes the integration for the peak. Then you obtain your titer, ambient for ratio, and the molecular weight of that mixture.
Oh, I see. Yeah. So based on what you said, with all those modules, you don't have to select a model for do any calculation. You just use that module to calculate. If you have AAVs, you have polymer and things like that. Oh, I see. So it's very convenient then, right? The other thing that like I also like when I walk in here and I met a few people out there, and actually I walked by the lab and I saw something new, and I don't remember I saw this one before. So is that a new MALS that TOSA is about to introduce?
Yes, we actually have our second generation of the lens.
Oh, I see. Wow. So can you tell me a little bit about that? Is it the same software, or what sort of improvement that you have on that one?
Yeah, for the hardware part, still the instrument have the same performance as the first generation, but we introduced more advanced functions. The function make me most excited is the laser adjustment. So because for some application, for example, AV or lipid nanoparticle, the sample have a huge size. So it's very easier makes the light scattering peak saturated. So you may need to lower the concentration of your sample. Some case it's not detectable by RI and UV because they are concentration detector. Now, in that case, the researcher developed the method for the split design. So you have the RI, UV, and the multi-angle scattering on two split. In that case, you can adjust the split ratio of the sample, and then you can get a reasonable light scattering and concentration peak. But this takes time. You need to make multiple injections to test which concentration works for both. And you need to adjust the back pressure for the detectors to make the flow right. But now, with the ability to adjust the laser, it's pretty simple. For example, you have 3 milliwatt here, 30 milliwatt here. You can simply reduce it by half to 15. Then the peak size reduced. In that case, you do not need to do any dilution. You can make all detectors in series.
Wow. That's great. I mean, like particularly, you know, like you don't have to use so much of sample, and all the modules is right there for you to do it as well. Okay. One more thing that I remember, sometimes that's, you know, like printing the report or obtaining, you know, like the report also is, you know, important, you know, in that kind of method. So is this one also, you know, incorporate all of that function in there?
Yes, it will be included in the SecView 3.1 and the future versions. We have a very fancy report function. You can actually modify everything in your report. For example, you can have like different color on the curve, different color, different like fronts for the labels, and you can add a personalized figure. For example, your company logo, your university logo, your funding logo, everything on the report.
So with the MALS LenS3 detector, is it designed for a specific HPLC, or it has the capacity that it be compatible with a lot of instrumentation out there?
Yeah, the lens is actually designed to compatible with all kinds of the front-end instrument, GPC, HPLC, and UHPLC.
Oh, I see. So as you said, is it can be connected with any HPLC, UHPLC, GPC systems. So it's just like a social butterfly. Am I right? I mean, it can land on anything. I see. So if you know, like somebody that said, hey, I want to couple this one with my HPLC or UHPLC. So maybe it's just a simple of hooking in and modify and mine a few things in there. Is that right?
Yeah, it's very simple. We only need a external signal output and then a trigger signal output. That's it.
All right. So I know that there is we have a limitation to time, right? So to wrap up, you know, today's section, do you have any advices for people who want to use, you know, malls, or even like for the people that, you know, who've been using malls already, but they looking for, you know, a new ways to improve malls? So you have any advice for people?
Yeah, actually, because we already have a well-established instrument and also the software, easy to use software, it's actually very easy to begin with, and also the knowledge is easy to transfer to your colleagues and to your customers. So it's not that difficult. And also, if you have questions, you can always contact Toso, and we are here to help.
So you meant that with your new innovation and compatibility with your instrument, I mean, why have to, you know, like use something more complicated? Because I look like, you know, the instrument that you just described to me, MALS, you know, LenS3. It's easy to use and compatible with many things, all the modules and things like that. I mean, I agree with you that, you know, why do you have to do something that, you know, difficult? Whereas, you know, with this new innovation, it truly, it make, you know, using malls very, very easy nowadays, right? All right. So one last thing, okay. In terms of method development and everything like that, give people the most, like challenging, the most cumbersome that most scientists, run into when they use small. So what is it?
Yeah, because multi-angle light scattering is sensitive to the size, so it's also sensitive to the undissolved salt in your buffer. So I will suggest always filter your mobile phase before connect to your system. That's it. Yeah.
All right. So if anything that people want to learn more, they can contact you, and then all the tips and tricks that you can provide to scientists out there.
Yeah, we are happy to help.
All right, that's great. All right, thank you, everyone. As you can see, that the podcast today with Tianyu Li and me, we will wrap up the podcast. So if you have any questions regarding MALS detectors or detections, please, like send us an email or give us a phone call. Tianju gonna be right here to, like advise you or to take on any question that you may have. With that, we thank you so much for your time.